The Music Room, Part 4. Let's pretend there's a way of getting through into it somehow, Kitty. And certainly the glass was beginning to melt away, just like a bright silvery mist. In another moment, Alice was through the glass and had jumped lightly down into the looking-glass room. Lewis Carroll. We've tried to distinguish left-right reversal as a procedure, what the mirror does, from left-right reversal as a consequence, visible in-object changes in the reflected form. We addressed the major difficulty that arises from this distinction, namely, if the mirror doesn't reverse by procedure, how could it reverse as a consequence? We tried to show that both what the mirror does and does not do are sufficient in combination to result by consequence in a, quote, reversed image. Finally, in characterizing this kind of in-object reversal as interaxis change, we acknowledged an ambiguity. Interaxis consequences are the fact. Left-right reversal, or up-down reversal, are the interpretation. This episode contains images, so it's best to listen and watch on YouTube. In this episode, we'll start by describing the generic consequences of reflection in 2 dimensions. We'll restate our aim informally but clearly, then bring symmetry in. The image on screen shows a letter reflected vertically, horizontally, and at an angle. We distinguish between these when we focus on the procedure by which they are reflected. For example, we might say, figure A has been reflected vertically across a horizontal line of reflection. The consequent image is top-bottom reversed, but left-right preserved. This is the exact opposite of what we would say about figure B. It is top-bottom preserved and left-right reversed, reflected horizontally across a vertical line of reflection. These are differences, but if we restrict our attention to the internal geometry of each reflected figure, we notice something else. Every method of reflecting the letter, as shown on the right, reproduces a rotated version of the same figure with the same internal geometry. You can write your name upside down or backwards and you will wind up with the same thing. Figures A, B, and C are lined up top-bottom corrected in relation to your screen. They all have that same quarter turn counterclockwise between the letter's top and the letter's right side as per the last episode. Oriented this way, we feel right in interpreting them as left-right reversed. Note that this applies even to figure A, which was by procedure, left-right preserved. The main point, though, is that each reflected form, in relation to its own internal geometry, excluding rotations, is identical. Here is a second view of the reflected figure just to show both. Now the letters left and right are correctly oriented on screen. It's the same ambiguity we described earlier. Now the apparently preferable interpretation has switched. We think it's up-down reversed. Though again, the main point is that the reflected figure, however oriented, is the same. Here's a diagram to generalize what we've worked out so far. The letter F can be generalized as a 2-dimensional figure conceived of as having 4 sides. Figure A shows how those 4 sides normally relate in the pre-reflected letter. Figure B shows how these relationships change. B focuses on the consequences of reflection, ignoring the rotation produced by differently angled lines of reflection. What we end up with, figure B, is what we might call the impossible rectangle. But, as we've already learned, we could also call it the half-plausible rectangle. Figures C and D show the interpretation options. It might be okay top-bottom, but if so, it's left-right reversed. Or, figure D, it might be okay left and right, in which case the up and down must be backwards. Let's pause to restate our aim clearly. We are trying to answer the question, why does the mirror apparently reverse left and right, but not up and down? One popular instance of the problem is words on t-shirts, for example. But I'm not focusing on the lettering problem as an end goal. I'm interested specifically in the other instance of the problem, the one that relates to the human form. The latter, our focus, put informally, is, why is my wedding band on my doppelganger's right hand? I see it as on his right, whether the mirror is before me, to my left, or whether I stand on it. Perhaps we are already beginning to suspect that the deeper questions are, why don't I easily see in my reflected image the procedure by which I am reflected, but rather gravitate to the apparent in-object consequences of reflection, and why, when multiple interpretations are available, do I select for one specifically, not others? The human form instance of the problem is a three-dimensional problem, and we must solve it in 3 dimensions. But before this, let's look at one final example in 2 dimensions that brings the idea of symmetry in. Here, 2 different letters are reflected across a vertical line of reflection. Red boxes indicate the reflected figures. The asymmetric letter F has been left-right reversed. So has the capital A, the same procedure but not the same apparent outcome. In figure 1, I've labeled top, left, bottom, right to show how the internal geometry of the form changes after reflection. But in figure 2, so long as the form is perfectly left-right symmetrical, it's not clear to me that it's been left-right reversed. The perceived left and right perhaps stay the same after reflection. I can immediately identify top and bottom, these are clear, but left and right, it looks like the same letter. We're in 2 dimensions, I said, so this is analogous with rather than identical to the problem we're working on. But I noticed that when I start talking about rings or wristwatches, I'm no longer talking about a perfectly symmetrical form. I'm talking about a specific selective point at which there is a pronounced asymmetry. By the way, it's interesting that right now it seems as though the only question that could plausibly emerge about the capital A is, why does the mirror reverse up and down, but not left and right? Yet, as soon as we add our own point of difference, everything changes and the opposite question comes in. Figure 1 now shows what we might call apparent selective swapping. I'm full of this kind of eccentric nomenclature. The figure seems okay, but the dot has moved. This illusory jumping seems to require 3 things. 1. Mistaken but apparent side recognition. We think perhaps the left and right are okay, but we're wrong, everything's swapped. 2. A selective point of asymmetrical difference that is reflected, the dot. It alone appears to have moved. And 3. Obviously a symmetrical axis. The dot gives away the left-right reversal without compellingly dispelling the mistaken impression that left and right may have been preserved. Figure 2 is there to remind us that the unmistakable top and bottom act something like fixed in-object anchors to help us get to grips immediately with the orientation of the form. Even when it's upside down, I identify its top and bottom immediately. In procedural terms, then, it's up-down reversed, but in object terms, its up and down are fixed, preserved points of clarity despite reflection. I can hang on to them. Figures 3 and 4 are the money shot inasmuch as they dramatize the difference between reversal as procedure and reversal as consequence. I'm using the term money shot against my better judgment to try to really draw attention to this figure. Look at the vertical mirroring that produces figure 3. The dotted line is meant to clarify the procedural reality. The image is left-right preserved and top-bottom reversed. Yet figure 4 shows the apparent in-object consequence. When I rotate the reflected form to compare them side by side, and I might do this work mentally, the reflected image is left-right reversed versus the pre-reflected form. Questions remain. Why should I want to set these figures side by side as a preliminary step to making a comparison? Why prefer to compare them in this specific orientation? And how, if at all, does the letter's left-right symmetry and that minimal specific point of asymmetry underwrite these decisions? Next time we try to address these questions and move into 3 dimensions.